This is Yukabuka and welcome to my home on YouTube. In this video, we will continue our investigation into the keyring subsystem in the Linux kernel, and and this is the second video of the series, so we will resume where we left off uh, in our exploration of the documentation. So in this video, we'll start by looking at the access permissions. Now, what they say is that every key has a few parameters associated with it. There is a user ID, a group ID, and a permissions mask. And you can see this if you go into the kernel source code and then look for the key struct. So it should be defined in key.h. And then you can see that over here you have the user ID, the group ID, and the permission. So there are ways to set now the permissions mask is a 32-bit unsigned value, and so if you have four kinds of uh, actors for which you want to set permission bits, then that means you have 8 bits per actor. And so the processor has 8 bits. The user, the group, and others each have 8 bits worth of values that you can store. But with uh, with 8 bits, you have quite a few uh, values that you can possibly set. But I don't. But as you can see here, all of those values are not being set. The only permissions that uh, correspond to a key are either view, read, write, search, link, or search set attribute. So there are 6 of them. So view effectively means you can view the description and the type of the key. That's it. It does not mean that you can read the payload of the key. You can just read the metadata of a specific key. Read permission allows you to go through and read the actual payload of the key. Write means that you can write into the actual payload of the key or the keyring. If it's a keyring, then it means you can link a key to a keyring. That's what it means. If it's a key, then it means you can write the payload of the specific key. The next permission is search. Search means that you have the ability to take a keyring and search for a specific key within any of its nested keyrings as well. Of course, you should have the search permissions on the nested keyrings as well in order to be able to effectively go through and search for your specific key. And then comes the link permission. Now, suppose you are associating a key with a keyring. In order to do that, what you'll be doing is you'll be adding an entry into the keyring that points to the key. And as a result, you need a write permission on the keyring and a link permission on the key. And so that's why you require something called link. The next permission is to set attribute, which means you are allowed to set the UID, GID, and the permissions mask, which means these 3 fields of a key. If you need to be able to set these 3, you should have the set attribute permission. So now that we've quickly browsed through the different permissions that pertain to the keys, let's skip over the SC-Linux support and the procfs files part. Maybe we'll come to that at a later point in time, and then we'll get to the meat of it. That is, how do you interact with the kernel from user space and create new keys, request the keys that you've created, and so on. So what they say here is that they have 3 specific system calls. You've add key, request key, and keyctl. Keyctl has an interface that is very similar to that of an ioctl. It's not an ioctl, but it looks very much like an ioctl interface. Add key and request key are more or less regular system call like interfaces. So if you look at the kernel source code, you can see that there is a file called security keys keyctl.c. Looking for syscall define, you can see that all of the 3 system calls or the interfaces for these three system calls are defined in this very single same file. You have request key, keyctl, and add key. Now, in these system calls, you can see that there is an argument called ring ID. For the add key one, you have one. For request key, you have the destination ring ID, and in keyctl you just have args, which are specific to the option. So the ring ID refers to the keyring you would want to associate the key with. Now this will become more clear as you look at the specific system calls themselves, but it's good to know that these specific values have a specific meaning. So for instance, when you call add key, if you supply the ring ID with one of these values, then it's going to mean that the created key needs to be associated with the specific keyring. So you call add key with the keyring ID as -1, it means that the created key is going to be associated with the thread specific keyring. Let's say you call request key with the destination keyring ID as -2, it means that the key that you have requested for from user space will also be linked to the process specific keyring. On the other hand, if you do not use any of these values, -1 through -7, then it effectively means that it's a keyring ID belonging to some other keyring. Okay, so now that we've raced through that, let's look at the three interfaces. We have add key, which does what you would imagine it does. It creates a new key, or it updates an already existing key. When it in both cases, you have the ability to link the key that you're creating or updating with a keyring, which is denoted by this serial number, right? So that's what this system call allows you to do. You can also set the type of the key that you're creating, right? And the type is effectively represented by a string. And we've looked at the various types. We've looked at three of the types in the earlier video. We've seen that there is the keyring type, there is the user type, and there is the logon type. And so you can specify as a string in the first argument the kind of key you want to create, or the type of key you want to create. It is possible to have a description of the key which is null, in which case the keyring subsystem will attempt to generate a description. It is also possible to have a payload which is optional, in which case you can supply a payload at a later point in time. If there is a payload, you also need to specify the length of the payload upon creation of the key. Earlier we saw that in the previous video we saw that when creating a key of type logon, they do suggest that the description should have a colon, which is prefixed by the subclass of the key. While this is not mandatory for user type keys, they suggest something similar over here, in that you have a description with a colon and some identifying information prefixing that colon. For example, you can have the KRP5TTT to represent a Kerberos 5 ticket granting ticket. So this does not seem mandatory, but this seems to be the advisable. This seems to be very much advisable. And the next, and of course, the return value of the system call is the serial number corresponding to the specific key. Another system call that is used to interface with the subsystem is the request key subsystem. And what it does is it searches the process's key rings for a specific key, uh, and it returns um the serial number corresponding to that, right? So the order in which it searches the process's key rings are: first it searches the thread specific keyring, and then it checks the process specific keyring, and finally it checks the session keyring of the process. Um, and they say that there is also a keyctl system call which performs the exact same action um, as described over here. Uh, the interesting part of this system call is that it does not exactly do just what its name suggests. For example, when you say request key, you would assume that it's something that takes in, say, a serial number and then returns some kind of information about that specific key. But that's not what it seems, that's not the only thing it seems to be doing. It's also capable of